This is our last Quideo for stats. So let's hop on into it. For our basic problem, we were asked that based on the three following situations, we were asked if we can use the methods of inference for population proportion for a significance test. So our conditions that we must look at for each problem is each one must be a simple random sample, must 10 times the sample size must be less than the population, and the sample size times our P and our N times Q must be greater than or equal to 10. So for number A, it told us that we tossed a coin 10 times in order to test the hypothesis that the hoe of P equals 0.5, that the coin is balanced. And so I tested out that NP is greater than 10 and NQ is greater than 10, and they both equaled 5, which is not greater than 10, and that means that we cannot use the methods of inference for a significance test. For letter B, it states that a college president says 99% of the alumni support firing of Coach Boggs. You contact a simple random sample of 200 of the college's 15,000 living alumni to test the hypothesis that the P is 0.99. So I went through the conditions. So number 1, SRS, that was stated in the problem, and when it said that you contact a simple random sample is what it said. The second thing I tested was that 10 times the sample size is less than the population, and so our sample size was 200 and our living alumni was 15,000, and so 10 times 200 is 2,000 and 2,000 is less than 15,000, so that one works. And then for our last condition, we had N times P is greater than 10, and so 20 times 0.99 is 198, which is definitely greater than 10. And then N times Q being greater than 10, we have 20 times 0.01, which is 2, and 2 is less than 10, therefore that one does not work, so we cannot use the methods of inference. And our last problem says, do a majority of the 250 students in a statistics course agree that knowing statistics will help them in their future careers? Then you interview a simple random sample of 20 students to test the hypothesis that P equals 0.5. So in the problem, it states that we interview a simple random sample. So therefore our first condition of simple random sample is stated, and we can check that off. For number 2, we have 10 times our sample size, which is 20, and which equals 200. And our population in this situation is 250, so that one works. And for our last condition, we have N times P is greater than or equal to 10. So we have 20 times 0.5, which is our P value, which equals 10, so that one works. And NQ is greater than 10, which 20 times 0.5 equals 10, and so that one works because they're equal. So letter C, we can use the methods of inference. And now moving on to our advanced problem. For our advanced problem, we have to state whether a type 1, a type 2, or neither error has been made. So for letter A, it tells us that a bank wants to see if the enrollment on their website is about 30% based on a small sample of customers. It tests that the hoe of P equals 0.3 versus the ha of P is greater than 0.3 and rejects the null hypothesis. Later, the bank finds out that actually 28% of all customers enrolled. So for this one, I said that it was a type 1 error because they rejected the null hypothesis when they should not have rejected. They should have failed to reject it because their ha said that P was greater than 0.3 when it was really less than 0.3, and so they should have failed to reject it. For the second one, I said that it was neither error because it says a student tests 100 students to determine whether other students on her campus prefer Coke or Pepsi, and finds no evidence that preference for Coke is not 0.5. Later, a marketing company tests all students on campus and finds no difference. So in this situation, she fails to reject the hoe, and also the marketing company also finds no difference, which means they failed to reject the hoe. And because they were correct, this shows that no error has occurred. And for our last problem that we are given, it says a pharmaceutical company tests whether a drug lifts the headache relief rate from the 25% achieved by the placebo. The test fails to reject the null hypothesis because the p-value is 0.465. Further testing shows that the drug actually relieves headaches in 38% of people. So in this situation, they failed to reject the hoe when they should have rejected the hoe, because the p-value is 0.465, but then in reality it relieves headaches in 38% of the people, and so that value is actually smaller, so they would have rejected the hoe. And last but not least, our AP question. For our AP question, it told us that researchers wanted to determine whether drivers are significantly more distracted while driving when using a cell phone than when talking to a passenger in the car. So what they did was they took 48 people and split them in half, and so they randomly assigned 24 people to drive in a driving simulator while using a cell phone, and then the other 24 drove while talking to a passenger in the simulator. And then they were asked during the simulation to exit the freeway at a particular exit. And then in the study, 7 of the 24 cell phone users missed the exit, while 2 of the 24 talking to a passenger missed the exit. So for letter A, we want to know if this is classified as an experiment or an observational study. And this would be an experiment, and that is because the researchers imposed something to determine how the people in the situation, like how the results would be, and so it wasn't just looking at them based off of what they were doing. The researchers gave them a cell phone or gave them the task to talk to a passenger, and because they gave them that thing they were trying to look at, it would be considered an experiment. For letter B, we were asked to state the null hypothesis, which that would be U sub 1 equals U sub 2, and the sub 1 is those that are talking on the cell phone, and then the sub 2 is those that are talking to passenger. So we're testing if they're equal, but then we also want to know our alternative hypothesis, and so that would be U sub 1, so those on cell phones, is greater than U sub 2, those talking to passengers. Then for letter C, now we want, it says that we might consider using a 2-sample z-test to answer the researcher's question, but in order to do that, there are conditions that we have to find for this test to be appropriate, and so it wanted us to go through these conditions and state whether state what the conditions are. So the conditions, there are 3 conditions. It has to be a simple random sample. The samples have to be independent, and NP and NQ have to be greater than 10. So in our problem, it was stated that it was a simple random sample because the people were randomly assigned to a group. Number 2, our samples are independent of each other. So far, we're 2 for 2. And then our last condition is that NP has to be greater than 10 and NQ has to be greater than 10. So I went and I found the P and Q values for those talking on cell phones and those talking to a passenger in their car. So if you look over here, we have our P of 1 is 7 over 24, which is 0.292. Q1 would then be 1 minus 0.292, which is 0.708.